The idea of a flat Earth has been around for centuries, capturing the imagination of many throughout history. It predates modern science and is based on a literal interpretation of ancient texts, which were written long before the advent of modern astronomy and physics. In this view, Earth is imagined as a flat disk with a dome-like sky overhead, often referred to as the firmament. Proponents of this theory often depict the North Pole at the center of the disk, serving as a pivotal point in their model. The South Pole in this model is not a point but rather an ice wall that encircles the outer edge of the disk, acting as a boundary to the known world. This model raises many questions about how gravity would work, as traditional gravitational theories are based on a spherical Earth. Additionally, it challenges our understanding of how the sun, moon, and stars move across the sky. It also contradicts countless observations and scientific evidence that supports a spherical Earth, such as satellite imagery, the way ships disappear over the horizon, and the phenomenon of time zones. Despite the overwhelming evidence supporting a spherical Earth, the flat Earth theory persists in some circles, often fueled by skepticism of mainstream science and a desire to question established norms. The debate between flat Earth proponents and the scientific community continues, highlighting the importance of critical thinking and evidence-based reasoning in understanding our world. Gravity is a fundamental force that pulls objects towards each other. It's what keeps us grounded and what makes things fall when we drop them. On a spherical Earth, gravity pulls everything towards the center of the sphere. This central pull is consistent and uniform, making life as we know it possible. This explains why objects fall straight down, no matter where you are on Earth. Whether you're in the northern hemisphere or the southern hemisphere, gravity acts the same. On a flat Earth, however, gravity would work very differently. The dynamics of gravitational pull would change drastically. If the center of the disk were the point of gravitational pull, objects would not fall straight down as they moved away from the center. Instead, they would experience a pull towards the center of the disk. Instead, they would fall at an angle, gradually shifting towards the center. This would mean that the further you are from the center, the more pronounced the angle of your fall would be. This would create some strange effects, like trees growing diagonally. Imagine walking through a forest, where every tree is leaning towards the center of the Earth, and water flowing uphill towards the edge of the disk. Rivers and streams would behave unpredictably, defying our current understanding of how water flows. Buildings and structures would also be affected, potentially leaning towards the center, creating a surreal and disorienting landscape. Even walking would feel different, as you'd constantly be adjusting to the changing angle of gravitational pull. The world would be a very different place on a flat Earth. Early astronomers with a global perspective. While the idea of a flat Earth persisted in some cultures, ancient Greek scholars were already making observations that suggested otherwise. They noticed that ships sailing over the horizon disappeared hull first, with the masts visible longer. This suggested that the Earth's surface was curved, not flat. One of the most famous Greek astronomers, Eratosthenes, even calculated the Earth's circumference with remarkable accuracy in the 3rd century BC. He did this by comparing the angles of shadows cast by the sun at different locations. His calculations provided strong evidence for a spherical Earth, a concept that became widely accepted in the scientific community. Wilbur Glenn Voliva, a flat Earth proponent in the 20th century. Despite the overwhelming scientific evidence supporting a spherical Earth, some individuals continued to advocate for the flat Earth theory. One such figure was Wilbur Glenn Voliva, a prominent evangelist in the early 20th century. Voliva firmly believed in a flat Earth and even established a community in Zion, Illinois, based on his beliefs. He preached against modern science, claiming that the Bible supported a flat Earth model. Voliva's teachings gained a following, and he even offered a reward to anyone who could prove him wrong. However, his claims were easily debunked by scientists and aviators who had witnessed the curvature of the Earth firsthand. Modern flat Earth theories, a resurgence of an old idea. In recent years, there has been a resurgence of interest in flat Earth theories fueled by online communities and social media. Modern flat earthers often reject scientific evidence that contradicts their beliefs. They often propose alternative explanations for phenomena that are easily explained by a spherical Earth. For example, they might argue that gravity is an illusion, or that the sun and moon are much smaller and closer to Earth than scientists claim. These theories often rely on conspiracy thinking, suggesting that governments and scientific organizations are hiding the truth about the Earth's shape. Why flat Earth theories fall flat? While flat Earth theories might seem intriguing at first glance, they quickly unravel when examined scientifically. One of the most compelling pieces of evidence against a flat Earth is the existence of time zones. On a spherical Earth, different parts of the planet experience daylight and darkness at different times due to the Earth's rotation. On a flat Earth, however, the entire disk would experience sunrise and sunset simultaneously, which is not what we observe. Furthermore, satellites orbiting Earth provide irrefutable evidence of its spherical shape. These satellites constantly transmit data and images back to Earth, confirming its curvature beyond any doubt. The curvature of the Earth is not just a scientific curiosity, it has practical implications for engineering and construction. One striking example is the Verrazano Narrows Bridge in New York City. This iconic bridge connects the boroughs of Staten Island and Brooklyn. When engineers designed the bridge, they had to account for the Earth's curvature, even though the distance between the towers is relatively short. The towers of the bridge are actually 1 5/8 inches farther apart at the top than at the bottom to compensate for the Earth's curvature over the span of the bridge. This subtle but essential design element ensures the bridge's structural integrity. The scientific consensus on a round Earth. The scientific consensus on a spherical Earth is overwhelming. Countless observations, experiments, and measurements have confirmed this fact beyond any reasonable doubt. From the observations of ancient Greek astronomers to the satellite imagery we receive today, the evidence is clear and consistent. The idea of a flat Earth has been debunked time and again, and there is no credible scientific basis for it. It is important to rely on evidence-based knowledge and to be critical of information that contradicts well-established scientific principles. The importance of critical thinking, embracing evidence-based knowledge. The debate surrounding the shape of the Earth highlights the importance of critical thinking and the need to evaluate information carefully. In today's world, we are bombarded with vast amounts of information from various sources. It is crucial to develop the skills to discern between credible sources and misinformation. When faced with extraordinary claims like those made by flat earthers, it is essential to demand extraordinary evidence. By embracing evidence-based knowledge and engaging in critical thinking, we can navigate the complexities of the world around us and make informed decisions based on facts, not fiction.